So today we're going to be working on the interior of a car. We're not on the outside under the hood as normal. As you can hear in the background, there's going to be a blower motor that is constantly active on this particular vehicle. I'm just going to jump right into it from what I discovered and what I'm assuming based off a process of deduction that's keeping this blower motor active. Even though it looked like a mess in here, it's not that bad getting these components off. This is the removal and replacement isn't the main premise of this video. It's the diagnostic aspect. So this blower motor stuck on. The owner had someone assess it, and they replaced the blower resistor with no avail. So with that said, I'm not sure what else was tried out, but I have been messing with this for a couple of hours and reading on this system to understand it. It was some basic information to diagnose this through the service information I got from Identifix, but nothing really in depth. Hopefully I'll be able to provide a little bit more insight. So we're at a minute and about 30 seconds. Let's just jump into it. So what happens if you turn the switch in the off position, it don't work. The fan still blows high. You can change the directions of the vent. They work perfect. You can cut the AC on. It works perfect. AC activates. You can change the temperature. Max AC works like it's supposed to. Everything changes for the exception of this blower speed here. It just stays on high. Let me get them off the vent here. So let me show you what I found out, and hopefully this is going to be a fix based off of what I know that's going on with this vehicle. So I'm going into the body control module, which should be here, BCM. Within there, I should find air conditioning, and we'll be able to look at some control head data. So in the live function, here's the fan signal is on. This is going to be a little bit of key information. The service information does describe this. So if I move this button here, nothing changes. The state don't change. One other thing, if I disconnect this, oh gosh, let's get this out. There we go. Try to do it without breaking it. If I disconnect it, the state doesn't change. The blower is still on. Here's the AC amplifier right under the control head. If I pull this out, oh gosh, it goes off, but the fan signal stays on. Let me show you another key thing that I noticed. I gotta let that deplete of energy and forget the state, because when I remove the control head here, it still wants to stay on. So just even from that, I mean, I can suspect the AC amplifier to be the problem, because if there was something wrong with the blower resistor, logically it may have stayed on, but that's not guaranteeing this conclusion here. So we're gonna go a little further, but before I do, let me plug this back in and see if it forgot the state. It's plugged in. Uh-oh. It was off, but then it went back on. I'm gonna have to probably leave it unplugged a little longer to prove this out here, prove my point. So let me shut the car off and let it just sit and deplete. I don't like having to cut it off and let it deplete, but because it makes me think that something else is going to be the problem. But based off of how this circuit works, let me get the key to shut up. So based off of how this circuit works, when you push a command here, it goes from here to this AC amplifier, and from this amplifier to the blower resistor in regards to the control speed, since that's what we're dealing with. The speed goes from low, medium, high. Command gets sent to the AC amplifier through control area network, and then the pulse width modulated signal is sent to the blower resistor, and the duty cycle is sent out to the blower motor to operate depending on the duty cycle commanded from this. So this works from a control area network from here to there. Duty cycle is sent from there to the blower resistor, and it works off whatever command state is given. All right, so I think we sat long enough. Let me plug this back in. So right now, oh, it's still on. See, that's what confuses me. Like, it's still on, even though, I mean, I left this unplugged, which made me suspect something else may be the culprit. But if I turn the vehicle off and let it sit for a while, just give me about 2 minutes and I'll come back. Plug this back in. So right now, the state is off. So it's been about a minute. So what'll happen, like it's going through a testing phase now with the blower, the actuators, and then the fan speed will start to work very slowly, and then it'll start to increase. Yep, it's on low now, so I'm gonna let this do its thing. But so it seemed like, and mind you, this is unplugged, so it seemed like all the issues is inside of here, because this is the only common thing that it has when telling that unit to work. But one big key thing here, I want to show you what that looks like from a oscilloscope perspective, because we know what's coming on, but we can't see it. So I'm gonna log in here. I got this pulled up. I got a 20 volt scale, and I'm on a 2 millisecond time base. And where I'm pierced in, I'm in the ground for my cigarette lighter, in that the positive side is pierced in the control wire. So it's only 3 wires at the blower resistors: power, ground, and it should be a PWM wire. So that's there. Let me see if I can show you where that is. As a matter of fact, it's 4 wires. There you go. But the main thing is I'm hooked in on that green wire, the small one. So with that said, I can't imagine, because it having power in some other source, like that being a problem, because the only thing I see that will activate that blower motor at the resistor is the pulse width wire coming from the AC amplifier. And this is what the signal looks like. This is a ground side switch here. And how I prove that, well, when it's on the state of being off, the voltage is high, and it don't start working until it's plugged in and it starts seeing a ground signal. So right now, this should be backfed voltage from the blower resistor, because it has power and grounds. Now that's probably likely due to it being a reference, just a reference circuit, like bias voltage, to ensure there's some continuity. And if there's some issue, it's going to detect like, hey, there's some circuit fault, I'm assuming. But this is our reference voltage here. So being that I have this disconnected, Let me plug this back in. Let's see what happens. Yeah, it shows that again. Let me cut it off all the way and just let it sit for a minute and get it back to that state. All right, so it's been like 5 minutes now. So let me try this again. Hit the on button. There's a sequence to this and I'm not figuring out. So all right, I'm plugging it in right now. So it's plugged in right now and we're not seeing, I'm gonna put it on a slower time base. So nothing's going on right now. The blend door and the mode door is going through a testing phase, it seemed like. There's no PWM coming from the amplifier at the moment. So we're just gonna wait on that. I should have it on. Yep, there it go. There it go. So it just came on. Let me stop this. Go back. It just pops on, just like that. Yeah, and it just come on. So it's blowing slow right now. What I will do, put it back on 2 milliseconds. I'm gonna plug this in because in a way this kind of throws me off, because if I plug it in, the fans start blowing higher. Am I going the right way? Let me flip it around. See how it started to grind itself out a lot more. So it throws me off, like, was this the causation for this to fail? Or is this just getting bad information causing the information from here to be misinterpreted? And that I don't understand. So I'm gonna run through it again. I don't know if this is gonna be, if this broke this, or if this doing what it's doing is a byproduct of some sort of unrecognition from this control head here. And I don't want to over intellectualize or complicate this, but this is just the stuff I got to think about here, because I don't want to. I want to replace the proper component. So I say to say, there's a donor vehicle at my local junkyard and it looks intact. I just went on the internet and found it. So tomorrow I'm going to replace the amplifier, and I hate to say it, but if it don't work, then I'm going to replace the control head. The car looked like it's in there for other reasons, not this. I don't know how common this is because it's my first time ever having to deal with this particular situation. But what I can do, probably find the CAN network wire on this control head here and see what that looks like, unplug and then plug it in and see if it changes state. See if I can get this close by here. So I'm tagged into one of the wires in the back. Oh gosh, I'm bending it. This seems to be an output for the LIN network. I'm assuming it's a LIN network. I didn't pull a wiring diagram, but I just pierced into something that looked like, I mean, it's gonna be a CAN here. So what I'm looking for is a change in frequency when I push these buttons. So I'm pushing the air direction or the mode, and it's not changing much. When I go to change the speed, you know, I don't see any frequency change. But when I change the temperature, you can see a change here. So what I'm gonna do, I'm gonna link up to a different wire and see if I find another network. And because it may be, because of the different wires on here, they may have their own individual command state through LIN network, and that's going to help me determine if this switch is having some sort of influence, and maybe because of this, how this works and how it changes the frequency, I can, if I move this or manipulate it, maybe that can deduce that the fact that this work, and I'll be justified in replacing this module here. So let me link up to some other wires in the back and see what happens. So I guess I'm right. I mean, I linked up to this brown one here in the back, and now when I push the buttons, like I'm pushing the defrost, I'm gonna push the recirculation. You see how it changed state, and I kind of notice it in the back here in the tail end of it. I'm gonna hit the, let me see, the fresh air. Let's hit the floor. All right, you can see on the tail end it changed, I'm assuming. Let's go with the fresh air. Let me move the speed button. And it is moving, but I don't know if that's because of just the natural communication or it's because I'm influencing it. But I'm moving the switch here back and forward for the speed. Let me hit the AC button. Let me hook up on another wire, see if I can change to see more of a blatant state. So I let the system sit for a little while. I'm going to try the same thing, but with the climate control head plugged in. So I want to see if the state of off will be on long. Okay, so it's off and it's going through its testing phase now, and the unit's plugged in. So while it's doing that, before it starts working, let me observe the can. Okay, yeah, that didn't change anything. So I just think I should replace, replace the amplifier. But my thing is, I don't like the fact that when I push buttons, you know, I can see some sort of change on this network. Like I'm moving the temperature now. That's changing. And let me see if I can do it with the mode. Look like these are getting thinner if I hit the defrost. Let me enhance this a little bit. Okay, now I'm going to hit the defrost and circulating or fresh air button. See if I can see any changes. Let me hit the mode. No, it might be on the other network. So the only one I see changing is if I change the temperature, and you see it on the far end there. Let me hit the AC button, the max. I've hit that. Nothing changed. I'm going to move the temperature. Yeah, nothing changed there. Well, this is as far as I'm going to be able to get today. Tomorrow, I'm going to grab the used part. And like I said, I'm grabbing both of those. And I'm just going to, I got to try it out because I'm not seeing any movement on the CAN network. Those pulses be influenced by me transitioning that speed. And then again, I mean, I have that plugged in on alone. It shouldn't cause that blower motor to work. So I don't have any history on the car, and I don't have anything conclusive. But the only thing I can do is buy the part. They allow me to return it, You know, if I don't need it, return it. I got to do it that way because this is a complex system. But I can only provide the information of what of this trial and error at the moment, and when I know it, I'm going to know it. So that's what I gotta do in this particular situation. Luckily, there's a donor car at the junkyard, and that's what a junkyard pretty much is going to be for. And I don't feel insecure about taking this route, throwing a part at it when I am on the right track. I feel as though I'm on the right track, and that's the only thing I can have is a little bit of conviction right now. So I'm going to get the part. We'll pull some data when it comes, when I get it, and see if we can see those changes. And maybe I can swap one at a time and see if that we can see a difference. But I would like, ideally, when I push those buttons, I do want to see those pulses either increase or decrease or make some changes. And it's not doing it with that. So let's see what happens. See you tomorrow. So what's the next day? I just got to the junkyard, got a new switch and a amplifier. So I will say the amplifier wasn't the causation of this. It was actually the switch, because I wound up changing the amplifier first and it still did the same thing. Let me pull this out here and show you. Okay, we'll pull that out, plug it into the old amplifier and let that go through its registration. And it's going through a testing phase, and it stopped. So now it works like it's supposed to. That works. That's fine. No big deal. I knew it was between one or two. That's not the problem. But the thing is, how do we diagnose this? And let me show you what I found out. So I'm still hooked up on the CAN network on the back. Let me show you the wire. This is going to be, focus, the green wire. That's what I'm hooked up on. Here's the CAN signal. Let me enhance this. So now what I'm going to do, I'm going to move the blower speed from off to on. We're on low. Going back to low. Here it go. There it go. There's the controller right there. I'm gonna go to off. See how that changed? There's the blower communication. I'm gonna go to, I'm off now, so I'm gonna go on. Kind of keep looking that same area. Let me see if it'll, see if it'll pass through. So here we go. I'm on now. You can see the pulse width changing. There's a state right there. There's the command. Let me go to high. There we go. Yeah, we can see, there it go. So there's our communication signal there. So that's the main thing I want to see, because diagnosing these new cars is nowhere near the same as like old school. Old school is gonna be easy, on off. Okay, you got a variable resistor from some sort of potentiometer, but everything's utilizing some sort of bus network. How do we analyze that? I'm glad I got this fixed. The key takeaway from this is that when you have to have oscilloscope, you have to have bidirectional scan tools to be able to access this module. So we need that at minimum, wiring diagrams, and an oscilloscope. I mean, I hate for it to be like that, for thousands of dollars of tools just to be, and resources just to be able to determine what's going on. But this is what the customer pays for. Unfortunately, I mean, I did have to guess in a way, but I knew for a fact it wasn't that. I knew what we had going out, but based off of, how this system works, I don't know. I'm just a general physician, just like a doctor. I don't work on one particular vehicle, but they all have the same principles, some functionality. So most of it is just strategy. So at least I got it narrowed down to the two things. But now in the future, when I have to diagnose one of these, I now know what I need to look for. I was on the right track yesterday with what I was speculating, looking for some sort of transitioning signal, and seeing what was talking, what was not talking. Being that I was able to see it with the other buttons, they worked, and with the, especially with the blend door, we just didn't see it with the blower speed. So now we know, and I'm gonna keep that information forever. So if anything happened with this vehicle, if it got to come back and LKQ part wound up taking a crap on me, which I doubt. I mean, it's OEM. We'll see what happened. Hit that link, subscribe to the channel, stay informed, how to reach on some of my work. See you on next one. I need to change out the skin. So I need to leave this so to match the client's car because these are different. So I'm gonna show you how to do that real quick with the old one. There's these two Phillips at the bottom. I'll take these two out, 1 and 2. Oh, okay. So just kind of find out the blower is actually working on low speed because this is not connected. So there might just be a default thing. Found something new out. So I'm gonna pull these tabs out and just pull up simultaneously. There you go. Pull that up. Then I can pull this out. I'm gonna do the same with the other one. I can pretty much just pull the knobs off and replace. Pull that, leave that there. This, and if I want to change the buttons, let me see how it looks with the black buttons on it. Don't look bad at all. I might leave that in there. So I can just pull that all the way off. That's the max AC. Pull straight up. Put this back. This should be indicated to where they're going to fit in their specific orientation. Like that. Yeah. Push down. Oh, okay. Why did it not go in there properly? Yeah, I guess if it's not right, that's going to stick out. So just turn it all the way off. Get the max line lined up. There you go. So if you turn it all the way off, then you kind of get an idea where it needs to be. All right, do the same with the other side. Turn it all the way off and get my dial in the off position. Yeah, no. There you go. And then, there you go. Okay, now I'm going to put everything back in reverse order. Circuit board goes in there. That plate. Slides in like that. Make sure it works. Then I'm just gonna put the screws back in and pop it back in like normal.